Every time fuel burns inside a motorcycle cylinder, it generates a massive amount of heat. If that thermal energy isn't constantly removed, the engine components you see glowing here will warp, fuse together, and ultimately fail. Unmanaged heat is the fastest way to kill an engine. Before it completely seizes, you will feel a severe drop in performance as the internal friction breaks. To solve this, manufacturers offer 3 different cooling systems. Modern motorcycle marketing heavily prioritizes liquid-cooled engines, presenting them as a mandatory premium feature for any serious rider. However, many experienced mechanics still view the basic air-cooled engine as the most reliable design on the road. That contradiction exists because reliability depends entirely on your environment and how you use the machine. If you are navigating daily city commutes on a strict budget, reliability comes from mechanical simplicity. You want a bike with zero risk of a leaking radiator or a broken water pump leaving you stranded. If you are touring on the highway at high speeds, reliability comes from thermal stability. You need an engine that can sustain maximum power for hours without the internal temperatures climbing toward a meltdown. We are going to analyze the internal mechanics of air, oil, and liquid systems so you can identify which setup actually fits your specific riding conditions and maintenance budget. Forcing the wrong cooling system into your specific riding environment is what actually destroys engines and wastes money. We start with the air-cooled engine, the foundational baseline of motorcycle engineering. This animated diagram shows a cross-section of an air-cooled cylinder. These metal fins on the outside are designed to expand the engine's surface area, allowing ambient air to catch and carry the heat away from the combustion chamber. Because this system relies entirely on the air passing over those fins, its cooling efficiency is directly tied to the speed of the motorcycle. The faster you go, the more heat is removed. This makes air-cooled engines the lightest option available. They are the cheapest to manufacture and carry zero risk of coolant leaks. The trade-off happens when you stop moving. In stationary traffic jams or severe summer heat, the airflow disappears, and the cooling efficiency drops to near zero. Getting stuck in traffic regularly causes recurring overheating. Over time, this thermal degradation reduces the engine's long-term life under stress. This lack of precise temperature control is why air cooling is rarely used for high-performance or large-capacity engines. An air-cooled system trades maximum engine longevity under heavy thermal stress for mechanical simplicity and a lower upfront cost. If you need more thermal control but want to avoid the weight of liquid cooling, oil cooling serves as a middle ground solution for medium-capacity bikes. This design takes the engine's lubricating oil and gives it a second job, actively carrying heat away from the hottest internal components, like the piston and cylinder walls. Look at this flow diagram. Hot oil passes around the cylinder walls, then gets pumped out to a small, radiator-like oil cooler mounted at the front of the bike. Ambient air passes through that front cooler to extract heat from the oil before it circulates back into the engine block. This provides more stable engine temperatures than basic air cooling. It improves durability and makes the bike capable of handling both city streets and open highways. The cost of that stability is added mechanical complexity. You are introducing external oil passages, a front-mounted cooler, and a mechanical pump, all of which can potentially fail. It also creates a critical mechanical vulnerability. If you skip your maintenance and the oil degrades, the engine loses its lubrication and its cooling system at the exact same time. Oil cooling delivers a balance of highway stability and affordability, provided you have strict discipline regarding your oil change intervals. For modern sports bikes and high-performance racing, liquid cooling is the mandatory choice. Instead of relying on oil or outside air, this system uses a dedicated coolant liquid. It flows through specific channels, called water jackets, that completely surround the cylinder and cylinder head. This schematic shows the complete closed loop. A water pump pushes the boiling hot coolant out of those jackets and into a large front radiator. There, a spinning fan helps cool the liquid before it returns to the engine. That active fan is the crucial difference. It allows the system to force air through the radiator and maintain a nearly constant engine temperature, even when the motorcycle is completely stationary in traffic. Because the temperature stays stable regardless of outside conditions, manufacturers can safely build engines with higher compression. This supports sustained maximum power output and excellent long-term durability. However, liquid cooling makes the motorcycle heavier. It is the most expensive system to manufacture and introduces failure points, like radiator leaks or water pump breakage, that will immediately sideline the bike. Liquid cooling guarantees thermal stability and engine longevity under extreme use, but it requires the rider to accept higher financial and mechanical liabilities. To find the right system for your needs, consider how you'd stay cool on a hot summer day. Air cooling is like standing in front of a fan. It helps, but if the heat is extreme, it gets overwhelmed. Oil cooling is like standing in front of that fan while drinking cold water. You're cooling your body internally. Liquid cooling is like sitting in an air-conditioned room. The temperature remains controlled, regardless of the heat outside. Evaluate your primary use case. For daily city commutes on a small-capacity budget bike, choose air cooling. For mixed city and highway riding requiring reasonable maintenance, oil cooling is your match. For extreme traffic, heavy touring, or high-speed performance, you need liquid cooling. Liquid cooling provides sustained performance and hardware longevity. Air cooling provides financial savings and absolute mechanical simplicity. A successful purchase depends on matching the cooling system's thermal capacity to the specific reality of how and where you ride.